Cities A and B are 45 miles apart. Alicia lives in A and Beth lives in B. Alicia bikes towards B at 18 miles per hour. Leaving at the same time, Beth bikes towards A at 12 miles per hour. How many miles from City A will they be when they meet? A travels at 18 miles per hour and B travels at 12 miles per hour. So together they travel 30 miles per hour, meaning that in 1.5 hours they cover 45 miles. So that means that after 1.5 hours, when they've met, they'll be 18 times 1.5, which equals 27 miles from City A, or choice E. Problem 2. The weight of 1/3 of a large pizza together with 3½ cups of orange slices is the same weight of 3/4 of a large pizza together with ½ cups of orange slices. A cup of orange slices weigh 1/4 of a pound. What is the weight in pounds of a large pizza? So 1/3 P plus 7/2R equals 3/4P plus half R. And because R, which is the weight of a cup of orange slices, is 1/4 of a pound, 1/3P plus 7/2 times 1/4 equals 3/4P plus half times 1/4. So 5/12P equals 3/4, meaning P equals 3/4 times 12/5, which equals 9/5, or 1 4/5. So the answer is A. Number 3. How many positive perfect squares less than 2023 are divisible by 5? Well, the perfect squares under 2023 are 1 squared, 2 squared, all the way up to 44 squared inclusive, because 45 squared equals 2025, which is over 2023. And because 5 is prime, any square that's divisible by 5, for example, if n squared is divisible by 5, then n itself must be divisible by 5. So, the positive perfect squares that are divisible by 5 are 5 squared, 10 squared, all the way up to 40 squared. And since 5 equals 5 times 1, 10 equals 5 times 2, and 40 equals 5 times 8, there are 8 such squares, so the answer is A. Problem 4. How many digits are in the base 10 representation of 8 to the power of 5 times 5 to the power of 10 times 15 to the power of 5? Well, this number is the same as 2 to the power of 3 to the power of 5 times 5 to the power of 10 times 3 times 5 to the power of 5. And that is equal to 2 to the power of 15 times 5 to the power of 10 times 3 to the power of 5 times 5 to the power of 5, which is equal to 2 to the power of 15 times 3 to the power of 5 times 5 to the power of 15. And that is equal to 10 to the power of 15 times 3 to the power of 5. And we know that 3 to the power of 5 is equal to 243. Every time you multiply by 10, you add another digit to the number. So if we're multiplying by 10 to the power of 15, then you're adding 15 zeros at the end of 243. So the total number of digits is 3 plus 15, which equals 18. So the answer is E. Problem 5. Janet rolls a standard 6-sided die 4 times and keeps a running total of the numbers she rolls. What is the probability that at some point her running total will equal 3? Well, the key is that at some point her running total is going to be 3. So she can roll a 3 after just one roll and then roll anything else. She can roll a 2 and then a 1 for a running total of 3, a 1 and then a 2 and then anything else, or a 1, 1, 1 and then something else. All of these are showing what a successful roll for Janet would look like. So for the first one, if she rolls a 3 first, then there's 6 to the power of 3 different combinations for the other 3 dice that she rolls. If she rolls a 2, then a 1, there's 6 to the power of 2 ways she can do this in a 4-roll combination. 6 to the power of 2 and 6. These are all the successful combos. The total number of combinations for a 4-die roll is going to be 6 to the power of 4. That's the total. And the successful combinations we're going to add. So 6 to the power 3 plus 6 to the power 2 plus 6 to the power 2 plus 6 is going to be our final answer. And this simplifies 6 squared plus 18. 6 squared plus 6 plus 6 plus 1 over 6 to the power of 3, which equals 49 over 216, or answer choice B. Problem 6. Points A and B lie on the graph of y equals log 2x. The midpoint of AB is 6, 2. What is the positive difference between the x-coordinates of A and B? Well, we can say that point A has coordinates xa, ya, and that point B has coordinates xb, yb. Since both of these points are on the graph y equals log 2x, we know that 2 to the power of ya equals xa, and we know that 2 to the power of yb equals xb. Because the midpoint of AB is 6, 2, we know that xa plus xb over 2 equals 6, and that ya plus yb over 2 equals 2. So this top quantity is 12, and this top quantity is 4. What we want to find is the positive difference between the x-coordinates of A and B. So that's either xa minus xb or xb minus xa, depending on which of xa or xb is larger. What we can do is we can write xa plus xb squared plus xa minus xb squared. And what's going to happen to this expression is that the xa squareds and the xb squareds are going to cancel out, and we're going to be left with 4xa xb. And this is really good because we can figure out what this quantity xa plus xb is, and we can also figure out what xa xb is, and that allows us to solve for the answer to this problem, xa minus xb. So first of all, we know that xa plus xb is 12. So we have 144 plus xa minus xb squared equals. Now we want to find xa times xb. And if we look at these two expressions here, if we multiply them, what we get is 2ya plus yb equals xa xb. And we know that ya plus yb equals 4. So that means xa xb equals 16. We can plug that into our previous equation to get 4 times 16 equals 64. So that means that xa minus xb squared equals 80. So this expression is equal to the square root of 80 or 4 square root 5. So the answer is D. The reason why we found xa minus xb and not xb minus xa is that it really doesn't matter which of them we find, as long as the answer we get is the positive square root of 80. What we don't want is for our answer to be the other solution to this equation right here, which would be negative 4 square root 5. As long as our answer isn't that, we're good. Problem 7. A digital display shows the current date as an 8-digit integer, consisting of a 4-digit year followed by a 2-digit month, followed by a 2-digit date within the month. For example, Arbor Day this year is displayed as 20230428. For how many dates in 2023 will each digit appear an even number of times in the 8 digital display for that date? So since we're only talking about dates in 2023, we know the first 4 digits will be 2023. And what we want to do is count for how many dates each digit will appear an even number of times. So we can categorize all these successful dates into what month they fall into. So for example, if our digits here are 0 and 1, well, we know that since we already have a 2, 0, 2, and a 3 in our date, we have to have at least another 0. And also we have to have at least another 3. So if our month is 0, 1, then for our day, we have to have another 3 and another 1. So that means our day can be 13 or 31, which gives us 2 successful dates. If our month was instead February, we would need another 2 and another 3. So then the day could be 23, but not 32 because that's not a valid day of the month. If the month is 03, so it would be like that, we would need another, well, we already have 2 zeros, we have 2 3s, and we have 2 2s. So we just have to make sure that in our day, each digit is the same. So the day could be 11 or 22. For dates from April to September, which are 04, 05, all the way to 09, they're not possible because you would need another 3 and another 4, or another 3 and another 5, or another 3 and another 9. But none of those create valid days. So 04 to 09 don't work. Moving on to October, which is 10, you would need another 3 and another 1. So the day could be 31 or 13. If the month is 11, you would need another 0 and another 3, so you would have 03 and 30. And for December, you would need another 0, 3, 1, and 2, but that's not possible. So in total, you have 9 successful dates, so the answer is E. Problem 8. Maureen is keeping track of the mean of her quiz scores this semester. If Maureen scores an 11 on the next quiz, her mean will increase by 1. If she scores an 11 on each of the next 3 quizzes, her mean will increase by 2. What is the mean of her quiz scores currently? We can define S as her current sum of the scores of all the tests she's taken so far, and N as the current number of tests that she's taken. So then we can write, using the information from the problem, that s plus 11 over n plus 1, meaning if she scores an 11 on the next quiz, her mean will increase by 1. And if she scores an 11 on each of the next 3 quizzes, her mean will increase by 2. So if we write the right side of each equation with a common denominator, then we get s plus 11 over n plus 1 equals s plus n over n. And s plus 33 over n plus 3 equals s plus 2n over n. Now, if we cross multiply each of the 2 equations, then we get Sn plus 11n equals Sn plus s plus n squared plus n. And also, Sn plus 2n squared plus 3s plus 6n equals Sn plus 33n. So from this first equation right here, we can write that n squared plus s minus 10n equals 0. So if we multiply each side of the equation by 2, then we get 2n squared plus 2s minus 20n equals 0. So now if we subtract this equation from this equation, then what we get is s plus 26n equals 33n. So s equals 7n. Since we want the mean of her quiz scores currently, we find that s over n equals 7. So the answer is D. Problem 9. A square of area 2 is inscribed in a square of area 3, creating 4 congruent triangles as shown below. What is the ratio of the shorter leg to the longer leg in the shaded right triangle? Well, we can call the longer leg x and the shorter leg y. So then we want to find x over y. We know from the diagram that x plus y equals the square root of 3, which is the side length of the longer square, or the larger square. And we also know that x squared plus y squared equals 2 from the Pythagorean theorem on this triangle, because the side length of the smaller square has to be the square root of 2. So using these 2 equations, we can solve for x and for y. So from this equation, x equals the square root of 3 minus y. So substituting that into the second equation, we get the square root of 3 minus y squared plus y squared equals 2y squared minus 2y squared root 3 plus 3, which equals 2. From there, we can expand our equation to get 3 plus y squared. We get 2y squared minus 2y squared root 3 plus 1 equals 0. So from there we can just apply the quadratic formula and get y equals 2 square root 3 plus or minus 12 minus 8 divided by 4. Since y is the shorter side, we're going to use the minus sign here. And we know that that's a valid solution, because if y equals 2 square root 3 minus 2 over 4, we know that 2 square root 3 is larger than 2, because the square of 2 square root 3 is 12, while the square of 2 is 4. So clearly 2 square root of 3 is larger than 4, so we have a positive value for y. So y equals square root 3 minus 1 over 2. Now x equals square root 3 minus y. So x equals the square root of 3 over 2 plus 1. So since the problem asks for the ratio of the shorter leg to the longer leg, so we're actually looking for y over x. We have y over x equals square root 3 minus 1 over square root 3 plus 1, which equals 4 minus 2 square root 3 over 2, which equals 2 minus square root 3. So the answer is C. Problem 10. Positive real numbers x and y satisfy y squared. Problem 10. Positive real numbers x and y satisfy y cubed equals x squared, and y minus x squared equals 4y squared. What is x plus y? Well, we know that either y minus x equals 2y or x minus y equals 2y. Because these quantities squared give us this equation right here. So if we have y minus x equals 2y, then y equals negative x. Or y equals 1/3 x. If we plug this equation into the first equation given in the problem, then we get negative x cubed equals x squared. But that would imply that negative x equals 1, and clearly that's not possible because x has to be positive. So we cross out this case. Then if we plug this equation into the first equation given in the problem, then we get 1 over 27 x cubed equals x squared. So 1 over 27x equals 1. That means that 27 equals x. And since we established that y equals 1/3 x, y equals 9. So x plus y equals 36, and the answer is D. Problem 11. What is the degree measure of the acute angle formed between lines with slopes 2 and 1 over 3? No matter where the line is, as long as we have lines with slope 2 and 1 over 3, it doesn't matter what their x-intercepts or their y-intercepts are, as long as the lines have those slopes. It doesn't matter where in the plane they are. So we can set them as going through the origin because that's the easiest to deal with. So we have a line of slope 2 that therefore must go through the point 1, 2, and a line with slope 1/3 that must therefore go through the point 3, 1. So now we can apply the law of cosines on triangle AOB. AO has length square root 5 using the Pythagorean theorem, because we see that if we have a side of 1 and a side of 2, the third side must be square root 5. Similarly, BO has length square root 10, and AB has length square root 2 squared plus 1 squared, which is equal to square root of 5. So we can apply the law of cosines with the unknown angle being angle AOB, because that's the angle that the problem asks us to find. So using the law of cosines, 5 equals 5 plus 10 minus 2 times square root of 5 times square root of 10 times the cosine of theta. So then we have 10 equals 10 square root 2 times the cosine of theta. So cosine theta equals 1 over square root 2, which equals 2 square root 2 over 2. So that means that theta must be 45 degrees. So our answer is C. Problem 12. What is the value of 2 cubed minus 1 cubed plus 4 cubed minus 3 cubed plus 6 cubed minus 5 cubed plus 18 cubed minus 17 cubed? The pattern is that there's x plus 1 cubed minus x cubed, and this is equal to 3x squared plus 3x plus 1. And in the problem, the values of x are 1, 3, 5, all the way to 17. So, essentially, we have a bunch of 3x squareds for different values of x, a bunch of 3x's, and a bunch of 1's. In total, we need to count how many values of x we can have. So this list, if we subtract 1 from each number, we get 0, 2, 4, 16. And if we divide by 2, we get 0, 1, 2, 8. So there's 9 numbers in the list. So if we go back to the expression that we want to find in the problem, we know that this whole sum is going to be equal to 3x squared for all the values of x, plus 3x for all the values of x, plus 1 for all the values of x. So the expression we want is equal to 3, 1 squared, plus 3 squared, plus 17 squared, plus 3 times 1 plus 3 plus 5 plus 17 plus 17 times 1. Using the expression for the sum of odd squares, we know that this expression is equal to 3 times 9 times 4 times 9 squared minus 1 over 3 plus 3 times 9 times 9 and then plus 9. Oh, sorry, this should be 9 because there's 9 items in the list. This is equal to 323 times 9 plus 243 plus 9. And eventually this is going to be equal to 3,159. So the answer is D. Problem 13. In a table tennis tournament, every participant played every other participant exactly once. Although there were twice as many right-handed players as left-handed players, the number of games won by left-handed players was 40% more than the number of games won by right-handed players. There were no ties and no ambidextrous players. What is the total number of games played? Well, we can set RW as number of games won by right-handers and LW as the number of games won by left-handers. So the total number of games, which we can call G, is going to equal the total number of games won, which is equal to the number of games won by right-handers plus the number of games won by left-handers. Moreover, since from the problem LW equals 1.4 RW, we know that G is also equal to 2.4 RW. Since 2.4 RW has to be an integer, we know that G is a multiple of the smallest multiple of 2.4 that is an integer, which is 2.4 times 5, which is equal to 12. So G is a multiple of 12. So that means that our final answer has to be either 36 or 48, which are the only answer choices given by the problem that are possible. Now, another way to calculate the total number of games played is to take the total number of players and to do total number of players choose 2. So, for example, say there's n total players. Then the total number of games played is equal to n choose 2. And n choose 2 is essentially n over n minus 2 n. 2. Which is equal to n times n minus 1 over 2, which equals 36 or 48. So this top quantity is either 72 or 92. Well, if n equaled 9, then we would get n times n minus 1 equals 9 times 8, which equals 72. But there's no way for n times n minus 1 to equal 92 if n is an integer. Therefore, the total number of games must be 36. So the answer is B. Problem 14. How many complex numbers satisfy the equation z to the power 5 equals the conjugate of z? So we can say that z equals r times e to the power of I theta. And that means that z to the power 5 equals r to the power of 5 times e I 5 theta. And since this is equal to the conjugate of the conjugate of z is r times e to the power of I negative theta. So we can divide by r, and we can move this term to the other side to get r to the power 4 times e to the power of I 6 theta equals 1. But we're only allowed to do this if r is not equal to 0. If r equals 0, then z equals 0. And moreover, z equals 0 satisfies the problem. So we have to remember to count that as a solution. Otherwise, r to the power 4 times e to the power of I 6 theta equals 1. So the magnitude of this number is 1. So that means that r squared has to equal 1. So we can multiply both sides of the equation by r squared equals 1 to get r6 times e to the power of I 6 theta equals r squared, which equals 1. So r e I theta to the power of 6 equals 1. So that means z to the power of 6 equals 1. So there are 6 complex numbers z's that satisfy the equation because any sixth root of unity is the number that satisfies this equation. So in total, there are 6 plus 1 which equals 7 solutions for z. Problem 15. Usain is walking for exercise by zigzagging across a 100 meter by 30 meter rectangular field, beginning at point A and ending on the segment BC. He wants to increase the distance walked by zigzagging as shown in the figure below, APQRS. What angle theta will produce in a length that is 120 meters? The figure is not drawn to scale. Do not assume that the zigzag path has exactly 4 segments as shown. There could be more or fewer. Well, let's look at one of these triangles, like a triangle right here. If this angle is theta, we can call this length x and this length y. I want to know how many segments of this length right here are going to fit in this entire 100 meter length. If this length is x, then there's 100 over x such segments. So that means that we could fit 100 over x such triangles, such right triangles along this field. Moreover, for every triangle that we fit along this field, we're going to be adding another length identical to AP right here. And AP, we can say that its length is y. So if we have 100 over x of these segments of length AP or y, and we want the total length to be 120, then we get this equation. So since the cosine of theta is x over y, then we know that cosine theta equals 100 over 120, which equals 5 over 6. So that means that theta equals the inverse cosine of 5 over 6. So the answer is A. Thank you for watching this video. If you have any feedback for me, please let me know in the comments, and please subscribe if you'd like. Thank you so much.